This neural network model is a simplified visual representation of how information flows through the brain, displayed on a computer screen. It features 3 layers of artificial neurons that mimic the basic structure of biological neural networks. The input layer at the top has 12 neurons, acting like our sensory organs by receiving initial stimuli. The hidden layer in the middle consists of 126 neurons, mostly excitatory to encourage neuron activity, with a few inhibitory to balance the system, similar to real neural networks. The output layer at the bottom, the largest with 480 neurons, shows the final result of the information processing. The network operates by randomly activating input neurons and propagating this activity through the hidden and output layers. A dynamic visual representation uses color changes to indicate neuron activity, providing an engaging metaphor for information flow in biological neural networks. This artistic simulation also features a Van Gogh-inspired visualization, combining neural processing with evolving artistic elements like curves, points, and swirling patterns on a black canvas, creating a visually stunning representation that changes over time. The HTML script behind this simulation includes 2 side-by-side canvases, one for the neural network and one for the artistic visualization. A Start Simulation button initiates an animation that runs for 60 iterations, increasing in complexity to enhance the visual appeal. The artistic elements are drawn using a color palette reminiscent of Van Gogh's works, featuring dynamic, evolving patterns that beautifully blend neural activity with art, offering a captivating interactive experience.